Okay, so this video is a review over the properties of exponents. So this is Algebra 1 material, but hopefully, hopefully this is a review for you. But you'll need this information to do a lot of the stuff in Chapter 7. So let's first talk about how do you simplify an expression that looks like this, where you have some multiplication inside with some exponents, and then you have everything raised to the second power. Well, the way that works is you take each thing inside and you raise it to the second power. So this is the same thing as 4 raised to the second power, x cubed raised to the second power, and y to the 5th raised to the second power. So and the reason for that is because when you take something and you multiply it, or when you raise it to the second power, that's the same thing as multiplying it times itself. And then that would be 4 times 4, or 4 squared, and x cubed times x cubed, which is x cubed squared, etc. So then you can simplify even further. Anytime that you raise an exponent to an exponent, you multiply here. So this 4 squared becomes 16. X cubed becomes x to the 3 times 2, which is x to the 6th. Y to the 5th becomes y to the 5 times 2, which is y to the 10th. So this is the simplified version of that expression. Okay, what about when you have a fraction here? Well, 6 over 3 is 2. So the numeric part of the fraction simplifies to 2. X to the 7th stays the same. Y to the 5th stays the same. Now, when you take something and you move it from the denominator to the numerator, or from the numerator to the denominator of a fraction, you simply change the sign. So I can take this x to the negative 1 and move it up here, and it becomes x to the positive 1. So now I no longer have a fraction. I have 2 times x to the 7th times y to the 5th times x to the 1. And now here I can use another property of exponents. X to the 7th times x to the 1. I can rewrite it like this because multiplication is commutative, so I can switch y to the 5th and x to the 1. Now if you have something x to the 7th times x raised to the 1, you add the exponents. So before we had x to the 7th, we had an example like this. In that case, you would multiply the exponents. In this case, when you have x to the 7th times x to the 1, you simply add them. That's because x to the 7th could be written like this: 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And the x to the 1 could be written like this. So you have 8 x's here. So it's the same thing as x to the 8th. So that's another property of exponents. When you multiply and the two bases are the same, you add the exponents. So 2 times x to the 8th times y to the 5th is the simplification of this expression. Okay, now we're going to multiply everything out. Negative 6 times 3 is negative 18. M squared times m is the same thing as the last example, where you add the exponents, and the exponents here are both 1. So 2 plus 1 is 3. And then again, 2 plus 1 is 3, so you have n cubed. So that's the simplification of this one. Okay, so now we kind of have a combination. You have this exponent first, and then we have multiplication. So what we have really here, let me use a different color that's a little easier to see. You have x to the 5th, and then this is saying times 2x times 2x times 2x. Okay, so that's another way to write that problem. Alright, so x to the 5th isn't going to change. Then we have 2 cubed times x cubed. So you distribute that 2. And now we have x to the 5th times 2 cubed. I'm going to use the commutative property of multiplication, and I'm going to switch those two. And then since the base is the same, you add the exponents. And that's what this simplifies to. Okay, another example similar to last one, you get 4. The p's, you add the exponents, p to the 4th. Q, you add the exponents. 1 plus 3 is 4 again. Here's the simplified version of that. Negative 15 over 3 is equal to negative 5. X to the 4th. Now if I bring this x up into the numerator, I get x to the negative 1. And then you add the two exponents together. 4 plus negative 1 is 3. You also could have thought of it as one of these x's canceling and being left with 3 x's on the top. Okay, so now we have this side of the expression first. I'm going to switch back to, let's just go with blue. Alright, so s squared and then raised to the third power, you multiply these two exponents because it's an exponent raised to another exponent. So it's s squared cubed, t cubed, and then times st. So s squared cubed is s to the 6th times t cubed, and then this is times s times t. Again, multiplication being commutative, you can rearrange it to look like this. And these two combined, since they have the same base, you add the exponents. Same base, you add the exponents. S to the 7th, t to the 4th. Okay, now let's multiply fractions here. With fractions, you multiply across, and you get s squared t cubed times s times r cubed over r times t. So this is an s, doesn't really look like it. Again, you add the two exponents, s times s squared times s gives you s cubed. Then we have t cubed, but it's over t, so one of these is going to cancel out and you're left with t squared. R cubed over r, same thing, r squared. So that simplifies to s cubed, t squared, r squared. And that is it for kind of a quick overview of the properties of exponents and a bunch of examples of how to do that.